Hello developers, welcome to Kothait channel. In this video, we are going to build a machine learning model which is going to predict the used car prices based upon the car's features. The car's features are like the brand of the car and the mileage of the car, engine capacity, maximum power, seat capacity, transmission type. By considering all these input features from the users, and our machine learning model is going to predict the used car prices. So without wasting further time, let's see the demo first. So here is the final web application looks like car price prediction machine learning model. Okay, this machine learning model is going to take the inputs from all this kind of features from the user and it is going to predict the price of the car. Okay, now let's select the brand of the car as Tata, manufactured year as 2016, number of kilometers driven around here, and fuel type is petrol, and seller type is trust mark dealer, and transmission is type is automatic, and owner first owner, and car mileage is going to be around 20, and engine capacity and maximum power and number of seats. Let's predict. So the price of the car is going to be the 12 lakhs, and if I reduce something, car manufactured here, and the price has been reduced to the 10 lakhs, and if I reduce the car engine capacity also, and the price of the car is going to be decreasing. So this is how our machine learning model is going to predict the car prices based upon the input feature selected by the user, and our model is predicting the values accurately. So this is the final tutorial looks like. Let's decode the machine learning model which we are going to build as part of this tutorial. First, we have a data set with the car's features along with the selling price of the car. And second thing is pre-processing. In the pre-processing step, what we are going to do is we have to perform the null and duplicate check on the data set. Now, in the null check process, what we are going to do is we have to identify if there are any null records are there in the data set or not. If there are null records are present in the data set, we have to handle those null records. And at the same time, we have to do the duplicate check as well. In the duplicate check, we have to identify if there are any duplicate records are there in the present data set or not. If there are duplicate records are present in the data set, we have to handle those duplicate records as well. All this comes under the umbrella of the pre-processing. So once the pre-processing of the data is done, the next step is data analysis. In the data analysis, we are going to analyze the data which we have. Okay, we have to identify what are the important columns and what are the unnecessary columns. So we have to avoid those unnecessary columns from the data set, because to improve the performance of the machine learning model which we are going to build. And once we identify the important columns, we have to split the data set into two parts. First part is input features and another part is output features. What are the input features that we have to feed it to the model and what we are expecting from the model. Okay, so once all this data analysis is done, the next step is splitting the data set into two parts, trained data set and a test data set. 80% of the data goes to the trained data set and 20% of the data goes to the test data set. Once the data set is ready, the next step is we are going to create the linear regression machine learning model. So this linear regression model is created. We have to train this model with the training data set. So once the training is completed, then we have to do the testing of the model with the tested data set. So once the training and once the testing gets completed, the next step is we are going to predict the values from the model. So once we are satisfied with the predicted values from the model, we are going to save this model and we will be deploying it as a web application, as you guys have seen the earlier part of the video. So let's jump into the coding. Okay, the next step is we have to install the necessary Python libraries which are required for this tutorial. So for this one, I'm opening the command prompt. So in the command prompt, type the Python libraries which are required for this tutorial. Okay, which are NumPy, Pandas for the data handling, and scikit-learn for the model creation, and Pickle to save this model. And the next one is Streamlit to deploy this model as a web application. If you press enter, all these Python libraries will be installed in your system. All these Python libraries are already available in my system, so I'm not going to install them again. So once the installation of the libraries is done, the next part is we have to import those Python libraries. Okay, let's import the Python libraries. Import pandas as feed in the short form, and import numpy as np, again short form, and from scikit-learn sklearn model selection, we have to import the train test split. Okay, which will be used to split the data set into trained data set and test data set. And the next thing is from sklearn, we have to import the model which is linear model, import linear regression machine learning model. Okay, So we have imported the necessary Python libraries which are required for this tutorial. The next step is we have to read the data. We have the file called car details here. So we have to read this file data into a pandas data frame. Okay. Cause data is equals to pd dot read csv. Let's copy the file path. Copying the file path and pasting it here. Okay. Pressing enter. Okay. Now we have read this complete car details data set into a cost data pandas data frame. So the next step is we have to see the data. Cost data dot head. So this will give us the top 5 rows from the data set. So here we got the top 5 rows from the data set. So the pandas data frame index starts from 0. Okay. And we have the first column as name. It says the name of the car. And second column says the year the car has been manufactured. Okay. And third column is selling price, the price of the car. Okay. And the next column is kilometers driven. So number of kilometers this particular car has been driven so far. And the next one is fuel type, whether it is going to be a diesel or petrol or CNG or LPG. Okay. And seller type, whether it is going to be individual or a broker. And the next column is transmission type, gear transmission type, whether it is going to be a manual or automatic. And owner type, he or she is going to be the first owner, second owner, third owner, or test car. All this kind of different types of owners. And next column is mileage. Okay. Which says the number of kilometers that particular car will give for the 1 liter of particular fuel. Okay. Whether it is the diesel or petrol. And the engine capacity. Next column is the engine capacity. And next column is the maximum power of the engine, torque power, and the torque here. And then the seat capacity. So these are the input data set that we have. Okay. So once we have this data set, we have to identify what are the columns which are required for us and which are not required for us. Okay. I feel the column which is required for is name is required. So we will be the name of the car. The brand car plays important role in deciding the car price, right? Of course, the year and selling price is important. Kilometers driven is important. Fuel is important. Seller type, transmission is important. Owner is important. Mileage is also plays an important role. Yeah, engine capacity and max power also. And the torque, I think torque will not make much sense, so we can drop the torque. And the seats capacity also will plays an important role in the car price. Okay, so we have identified the torque is an unnecessary column which is not going to make much difference, so I'm going to drop that column now. Okay, costs data dot drop columns is equals to torque and in place is equals to true. Now let's print the top 5 rows. So we have dropped the torque column now. Okay, let's see how many columns are there and how many records of the data set that we have. So for that one, what we have to do is cost data dot shape. This will give us the number of records data set which we have with respect to the number of columns we have. Okay, so total we have 8128 rows of data with 12 columns. Okay, now it's time to do the pre-processing. As part of the pre-processing, what we are going to do is we are going to perform the null check. So what we are going to do here is we are going to check if there are any null values are there in the data set or not. Okay, for that one, what we are going to do is cost data dot is null dot sum. So it will give us the null values count with respect to the column name. Okay, so first 8 columns are not having any null values. So last 4 columns are having the null values. Mileage, engine, max power, and seats. These columns are having the null values. So how we are going to handle these null values? There are 2 different ways we can handle the data set if it is having the null values. First thing is whether we can replace it with the main value, and second thing is we can drop if we have the huge number of records. So as we have the 8128 record data set, we are going to drop these records. Okay. So how we are going to drop these records is cost data dot drop any. So it will remove the null values. Okay, and in place is equals to true. So what exactly in place does is it will perform this dropping the null operations on the main data set. So that's what this in place does. Okay, let me drop them. Now after dropping the null records, what is the record count we have? So the record count has been reduced to 7907 from 8128. Okay, now we have done the null check. The next step is duplicate check. duplicate check. Here we are going to check there are any duplicate records are there or not in the data set. Okay, for that one, data set cost data duplicated dot sum. Okay, it will give us the count of the data set which are having the duplicate values. So 1189 records are duplicate records. So we have to drop these records as well. So how we are going to drop these records are cost data dot drop duplicates. Okay, we are going to drop the duplicates again in place is equals to true. It's done now. Let's check the latest count after dropping the duplicate records. So we are left with the 6818 records with the 12 columns. So no null records, no duplicate records. Okay, cost data. So now we have the data set. Let's check the data type of these columns. Okay, for that one, what we have to do is cost data dot info will give us the information about the each and every column. Okay, the first column, so total we are having the 12 columns. Okay, and name is object. So year, selling price, kilometer driven is an integer column, and fuel, seller type, transmission, owner, mileage, maximum power, it is object type, and finally seat capacity is also a integer column or float column, numerical column. So what I am going to do next step is I have to do the data analysis here. Okay, data analysis. So to do the data analysis, what we have to do is we have to understand what are the different types of values are there for each and every column. Okay, first let's see that insights. For column in cost data dot columns, okay, print unique values of column and print cost data column name dot unique records and print the new column. So what we are going to do here is first let's fix this error. So for every column in the cost data dot columns, we are going to just check the unique values. Okay, and what we are doing is we are printing the unique values from that particular column. Okay, then we are printing this separator. Now let's see what exactly the error is. Data frame object has two attribute columns typo. Okay, yes, now we have the data set. So unique value of the name. Okay, so total we have the 6718 records. So these are the names: Skoda, Honda City, Hyundai, Maruti Wagon. So we have huge number of different values. Total 8125 values are the unique values. Okay, sorry, 6718 records are the unique values. So we have more number of unique names, okay, of the cards. And the next one is unique values of the year. One second, let me do it like this. Yeah. Next thing is unique values of the year. So the year starting ranging from 1994 to till 2020. Okay, the cards are available from 1994 year to 2020 year. Okay, and next thing is unique values of the selling price. It looks fine. Okay, all numerical values. Same goes for the kilometers driven. Yeah, numerical values. Okay, and the unique values of the fuel. So diesel is there, petrol is there, liquid petroleum gas is there, and compressed natural gas is there. So we have 4 different types of fuel types. And the seller type, individual and dealer and trust mark dealer. Okay, and the unique values of the transmission, whether the gear type is manual or automatic. And the unique values for the owner column is first owner, second owner, third owner, fourth and above owner, and test drive car is also there. And these are the unique values of the mileage. Okay, kilometer per liter for the where the fuel type is diesel or petrol, and kilometer per kilogram for the LPG. Okay, for liquid petroleum gas. And these are the unique values of the engine capacity, and these are the unique values for the maximum power, and these are the unique values of the seats. So now we got the insights about each and every column. Okay, now let's see what we can do. Okay, the first thing is the name of the column, unique names. Okay, we are having huge number of columns. If you see here, the dots are coming in the list, so that means there are huge number of columns are there. So what we are going to do is we cannot have all these columns. Okay, different columns. So what I'm going to do is, if you observe carefully here, every name of the car in the first word says the brand of the car. So first one says Maruti Swift. Sorry, first one says the Maruti Swift. So Maruti is the brand name. And second one, Honda City. Honda is the brand. And Ford Freestyle. Ford is the brand. Toyota. Toyota is the company name. Okay. So Tata Nexon. Tata is the brand. So we are going to extract this brand name from the name of the car, so that we can have the only the brand names instead of the complete car name. Okay, that is the one thing we can do for the name columns. And next step is, for the names, what we are going to do is, once we come up with the brand names are going to be the categorical columns. So before feeding it to the model, what we have to do is, we have to convert this categorical columns into always into the numerical values for the machine learning model performance. Okay, that is the next step we are going to do. Okay, next, we don't have to anything to do. Yeah, for the fuel column, here we have the categorical columns: fuel, seller type, and transmission, owner. All these four are categorical columns, so we have to convert these categorical columns into the numerical values. Okay, and the mileage column, if you see here, this mileage column is having the alphabetical characters and numerical values. So what we are going to do is, we are going to extract this only this first numerical part. We are going to ignore this last part, categorical part. Okay, that's what we are going to do for the mileage column. And same goes for the engine. So we are going to extract the first numerical part out of this engine capacity. And same goes for the max power as well. We are going to extract this numerical value. Okay, we are going to ignore this BHP. Okay, and there is nothing to be done for the seats column. Okay, now let's create a function to get the brand name of the car from the name of the car. Okay, get brand name from the car name. Okay, car name is going to be equals to car name dot split. We have to split that, right, with the space. Okay, first word. So then we have to return this name, return car name. We are going to strip. If there are any extra spaces are there, we are going to remove those extra spaces with the strip. Okay, we have created a function. Now get brand name. Let's take one unique value and just see that how this function is going to work. Okay, so it has to give us the Maruti. Here the Maruti is the brand name, right? Okay, strip. So here we are going to get the list of the words from that particular string, right? So we are going to need the first word. So for that one, I am just going to set the index as 0. Then it will work. See, we are getting only Maruti. Suppose if it is adding extra space. Oh, sorry, extra space should not. It is going to split that. Okay, we are going to get the Maruti alone. Okay, so our function get brand name is working to extract the brand name from the name of the car. So now let's apply it to the entire data set. Okay, cars data with the name is equals to cars name data with the name data set dot apply completely for the get brand name. Okay, now it works fine. Cars data name dot unique values. So now we are left with the brand names instead of the name of the cards. Okay, that's what we have done for the car names. Next thing is, what we have to do is values, this column is fine. So here mileage, so we have to extract the first word here also. I think same function will work for this mileage as well. Okay, let's apply that. Let me copy paste here and here mileage. Okay, sorry, typo. Have updated for the mileage, and same thing goes for the max power as well. Okay, and same goes for the engine capacity. So now we have done the data cleansing. Now let's print all the unique values again. Okay, let me copy this code from here and paste it here. Okay, so let me paste it here. Okay, So here instead of the names we are left with the brand names, and here the name of the year of the car manufactured and selling price numerical values we are good, and same goes for the kilometers driven, and fuel, seller type, transmission, owner. Yeah, we are only left with the numerical values for the mileage, and same goes for the engine capacity, and same goes for the maximum power of the engine as well, and the seat capacity also. So now we are left with the numerical values, but there are some categorical columns which we have to convert them into the numerical values. Okay, let's convert first this brand names. Okay, let me copy it here. Let me copy it here from here. Commas are there. Okay, just copying them. Okay, what I'm going to do is cars data with the name of the brand name dot replace. We are going to do the replace function with these values. What we are going to do is we are going to replace with the ones and twos. Okay, numerical values. So next in place is equals to true. Okay, now what we are doing is we are replacing the Maruti with the 1, Skoda with 2, Honda with 3, and same goes for Opel with the 31. Okay, so we are replacing this Maruti with the categorical column values with the numerical column values. That's what we are doing here. Okay, now once we are done with the name field, what is the next one? Transmission type, right? Codes data for transmission dot unique. Okay, now we have to replace codes data with the transmission with replace. Okay, manual and automatic with 1 and 2. Okay, going to apply in place is equals to true. Okay, now what is the next one? Seller type. Okay, for the seller type also let me copy paste this, replace it here. Okay, here we have 3 values, so we have to replace it with 1 comma 2 comma 3. Okay, we have to change the column name to seller type. Instead of the transmission it should be seller type. So once we are done with these ones, now let's see if there are any columns. Okay, still our object type, and yeah, fuel type we have to change. Okay, let's update that as well. Fuel type codes data fuel dot unique. So here also we are left with 2 values. Let's replace them. 1 2 3, total 4 are there. Okay, we have to replace with the 4. 2 3 4 home. Here goes the fuel. Now let's print this info. Here if you see here, so all these values are converted into the numerical values. Owner, mileage, engine, max power, all these are still showing the numerical values. Okay, object data type, so I think that's fine because we have the numerical values only, so that's not going to be a problem. Okay, so the next step is we have done the data analysis. Now we have to print the data set. Okay, codes data set. Okay, we have 6718 rows with 12 columns. Okay, and here reset index in place is equals to 2. Let me replace this index. Okay, now let me print this cost data. Now we have 6718 6717. Oh, it looks fine. Okay, something went wrong where we are getting owner. Okay, so we have to replace the owner as well. Okay, as we have done for the other columns, so we have to replace for the owner as well. Okay, let me do the replacement. Cost data for owner column is equals to dot unique values. Let's print the unique values first. Now next, cost data of the owner dot replace, going to replace the first owner to test drive car. Okay, with what? 1, 2, 3, 4 and 5. Okay, next in place is equals to true. Now let's print the cost data dataset. Okay, now we have all the numerical values. We can drop this index column. Okay, drop columns is equals to index in place is equals to true. Cost data. Okay, now we have the name, year, selling price, kilometer driven, fuel type, seller type, transmission, owner, mileage, engine capacity, maximum power and seat capacity. So now once we have this data set, let's split the input features versus the output feature. So selling price is going to be the output column and remaining 11 columns are going to be the input columns. So let's do that. Input data is equals to cars data, drop columns is equals to selling price. Okay, except this column, all the remaining columns are goes to the input data set. Okay, but output data set will have only the selling price column. Okay, cost data, selling price. Okay, we have split the data set into input data set and output data set. So the next step is we have to split this data set into train data set and tested data set. Okay, x train and x shape, y train and y shape is equals to train test split with the input data, output data and test size is equals to 0.2 because 20% of the data set goes to the tested data set and 80% of the data set goes to the train data set. So once we are done with the splitting, the next step is model creation. Model creation. The model which we are going to create here is linear regression machine learning model. Okay, linear regression machine learning model has been created. Now let's train the model. Okay, train the model with the train data set, which is x train data as input data set and y train as the output data features. Okay, x train comma y train could not convert string to float. Somewhere we have a space. We don't know for which column it is, right? Could not convert string to float. Okay, okay, let me change it to create another function. Okay, for the get brand name, going to add a function as clean data. Okay, and here instead of this value, copy this value, paste it here, going to split it, going to strip it, then I'm going to convert it into float for the remaining columns except the car name, which we are converting anyways to space, right? So let me remove the space as well here. Now let me re-execute all the steps. Now we should be good. Cost data, then done, it's done. Cost info, columns is done. Yeah, get brand name, yeah, it's completed for this one. Here instead of brand name, we'll just use the clean data function. Oh, okay, somewhere else we are having wrong value, could not convert. Okay, here brand name only, here it is fine. When it comes to here, use the clean data function, and same goes for here, same goes for here. Okay, float object has no string. Okay, I think I got the error, so we have to remove this single quotes here. So that's the mistake which I have done. Okay, okay, here if you see here there is a null value is there, so that's the reason it is saying. Okay, for that one what we are going to do is value.strip home value is equals to value.strip, and here if value equals to blank, then we'll make value is equals to 0. else value is going to be okay. We don't have to do anything. Okay, now let's convert this value pass to here, float of value. Okay, now let me start executing from the starting. Okay, okay, sorry for the confusion guys. The confusion was here, there was a some space was there, so without php there is no zero value is there for the maximum power, so there it has created some mess up. So we have created a function, we have converted all those values to the numerical values. Now we should be good. So we have created the model and we have trained the model with a trained data set. Now let's predict the values. Okay, predict is equals to for the test data set, model dot predict for the test data set x test. Okay, x test is not defined now. Why? Okay, here I have given x shape, it should be x test, y test. Okay, now we are done with the predictions. So we have predicted the values for the trained data set, sorry, tested data set. Now we have to create an input data set. Let's pass that random values to the model and how it is going to predict the price of the car. Okay, for that one we need the list of the columns, right? For that one I'm just typing xtrain dot shape, xtrain of 1 dot head of 1. Okay, only one record. Okay, so we need input model is done. Now let's feed it to the model. Let me change some values here, change to 2015. Okay, next model dot predict input data model. Okay, so the value of the car is going to be 6,67,305. Now let me reduce the number of kilometers to just 12,000. Okay, if you see here the price of the car has been increased because if it has been driven for more kilometers, so the engine might have been damaged, right? So the performance of the engine might have been reduced now. So that's the reason the more number of kilometers that particular car has been driven, so the price of the car will goes down. Okay, and now car capacity, seat capacity, let's change it to just 5. Okay, same thing. So if you change something, some alterations, if I change it to 2022, I think it will read. So the price of the car has been increased because the latest car will have the more price than the oldest car. Okay, so our model is predicting the values fine now. So now we have to deploy this model as a web application. Okay, let's save this model now. Model.predict, sorry, we need the import pickle pk dot dump of and model and open model.pickle, and we are saving with the right binary access. If you see here, it has created a new file called model.pickle with the model. So whatever the machine learning model which have created, largest linear regression machine learning model, it has been saved. Now this will be used to deploy it as a web application. Okay, now let's deploy it as a web application. Let me switch to the Visual Studio. Let me create a new file called app.py. Okay, here we have to import the necessary libraries, pandas spd and import numpy as np. So we can copy most of the things from this copybook layout. Okay, and we need these two, and we need pickle as well. Import pickle as pk. Okay, and yeah, once we have all these things, like the next step is we have to load that model. Model is equals to pk dot load of open model dot pickle with the read binary access. Okay, now we have to import the streamlit, okay, which is required to deploy this as a web application. Streamlit as st and st dot header. Let's core price prediction model. Okay, saving it and let me run it. Okay, no errors. Now, if you're executing any Streamlit app, so I have to type this command in the command section. Okay, Streamlit run app.py. If you press enter, there will be a new tab will be open in your default browser with the model core prediction. So we have to change it to core price prediction machine learning model. Okay, here I have to go to the settings, rerun on file. So it will be re-executed every time when you change the source file. Okay, core price prediction machine learning model. So once it is done, now we have to read this file, right, for the car names. So let's take this one and we need a function to get the brand names, right, out of it. Copy that functions. Yeah, get brand name. Okay, once we have the brand name, we have to apply this one too. So this is a repeat. So what we have done is, so we have imported this file data into a cost data pandas data frame, and we are using the get brand name to get the brand name of the cards. Okay, now create a input data set. st dot select box, select the car brand which you want. Okay, car brand, and data is going to be car state of name. Okay, dot unique. Rerun. Object is non-iterable. Cost data name dot unique. Yeah, if you see here is the brand names of the cards. Okay, next what we need, once the name of the car is done, so we have to go drop down. Okay, what are the input data set, name of the car, and here it has been manufactured, right? Okay, st dot slider car manufactured year from 1994 to 2024. Okay, let me save it. See here, you could see a slider for the year of the car. What is the next one we need? Number of kilometers it has been driven. Okay, just copy paste. Number of kilometers driven from 1 to, let's have 2 lakhs, 2020 2 lakhs. Okay, that is done. Now what we need, fuel type. Instead of name, here we are going to take the fuel. Okay, diesel, petrol, LPG and NPG. Next, seller type. Seller type. Next, transmission type. Transmission type. Okay, so we have the individual seller, dealer or trust mark, manual type or automatic. Okay, so next what we need the mileage and engine capacity as well. For mileage, engine capacity, and max bore and seats. Okay, select the mileage, car mileage from 10 kilometers to 30 kilometers or 40. I'll take it. Okay, and next is engine capacity, engine cc from 700 to 5000. Okay, next maximum power, torque power, max power from 0 to 200. Okay, and finally seats number of seats from minimum 5 to, let's have 10. Okay, these are the input details that we have. Now once we have all these input details has been extracted from the user, now we have to pass it to the model, right? So that's what we have to do now. We have to have a button here. If st dot, if that button is pressed, which is predict button. Okay, if this button is pressed, then only the next operation should perform. Okay, and here we have to assign the values. Okay, and let me copy these things here. So these are having the categorical columns, the car band and seller type, transmission type, right? So we have to convert them as we have done in the notebook. Okay, let's copy those things as well to here instead of doing it manually again. Okay, for that one, I have to pass these names to here. Pandas data frame out of it, and st dot write of input data model. Let's see how the data is going to look. Click on predict. Yeah, this is the data. So if you see here, name and fuel, seller type, transmission owner, which is having the categorical columns, which we have to convert it into the numerical values. Okay, which we have done here. Now that is done for the owner, and next we have to do it for the fuel. Once we have done for the fuel, what is the other one? Seller type and transmission type, and finally the brand. Okay, so here we have the cost data. Let's replace it with this name. Okay, copying it, and now instead of having it here, cutting it. Now let's see what is going to be the values. If you see here, we are getting all the numerical values. So we have to pass these values to the model. Okay, model prediction, predict model dot predict of predict price, car price. Okay, of input data model. Okay, and st dot markdown of car price is going to be let me remove this one over here. Now let me refresh it. So here is the final web application looks like, car price prediction machine learning model. Okay, this machine learning model is going to take the inputs from all this kind of features from the user, and it is going to predict the price of the car. Okay, now let's select the brand of the car as Tata, manufactured year as 2016, number of kilometers driven around here, and fuel type is petrol, and seller type is trust mark dealer, and transmission is type is automatic, and owner first owner, and car mileage is going to be around 20, and engine capacity and maximum power and number of seats. Let's predict. So the price of the car is going to be the 12 lakhs. And if I reduce something, car manufactured here, and the price has been reduced to the 10 lakhs. And if I reduce the engine capacity also, and the price of the car is going to be decreasing. So this is how our machine learning model is going to predict the car prices based upon the input features selected by the user, and our model is predicting the values accurately. So this is the final tutorial looks like. If you like the content in this video, please do like and subscribe to our channel. Thank you. Thanks for watching this video.